Welcome back. This is the final video about relationships inside of triangles. First, today we are going to talk about inequalities, about the measures of angles in a triangle and outside of a triangle. Just so you know, an example of an inequality, for example, is like if 5 equals 2 plus 3, then I know 5 by itself must be greater than 2 by itself, because 2 and 3 together make 5. So 2 by itself has to be less than 5. Similarly, 3 by itself has to be less than 5. This will probably help you understand the exterior angle inequality theorem. It says that the measure of an exterior angle of a triangle has to be greater than the measure of either of the remote interior angles. Remember, we learned in the past that the measure of angle 2 plus the measure of angle 3 adds up to the measure of angle 1. 2 and 3 are the remote interior angles, and angle 1 is the exterior angle. That's exterior angle theorem. Based on this equation, I know that angle 2 and 3 together make the measure of angle 1. So the measure of angle 2 by itself must be less than the measure of angle 1. Similarly, the measure of angle 3 alone must be less than the measure of angle 1. And since 2 and 3 are both less than the measures of angle 1, that means angle 1 is greater than the measure of angle 2 and the measure of angle 3. Let's do a practice problem here. It says list all angle measures that satisfy the following conditions. We're looking for measures that are less than the measure of angle 7. So when I'm looking for angles that have measures less than another angle, I'm looking for remote interior angles that have angle 7 as an exterior angle. So what helps me is to highlight different triangles or redraw them. So the first one I'd like to look at is this one, LKM. I redrew it here as well. I see that in this simplified version, I can really tell that the measure of angle 4 plus the measure of angle 5 equals the measure of angle 7. 7 is an exterior angle, and I know the measures of angles 4 and 5 individually must be less than the measure of angle 7. So I know 4 and 5 must have measures less than the measure of angle 7. I could also look at this larger triangle, triangle JKL, with an extended side to create angle 7. When I look at this triangle, I see that the remote interior angles are angles 1, and then angle 2 and 4 together make angle JKL. The measure of angle 2 plus the measure of angle 4 creates the measure of angle JKL. Therefore, angle 1 must have a measure less than angle 7, and also angle 2 and 4 individually have to have a measure less than angle 7. So putting all these together, I know that angle 1, angle 2, angle 4, and angle 5 all have measures less than the measure of angle 7. Next, I'm asked to find any angles that have measures greater than the measure of angle 6. So this time, when I'm looking for angles greater than, I'm looking for exterior angles. So I'm trying to find any exterior angles that have angle 6 as a remote interior angle. So I might start by looking at triangle LKM. Now I could extend this side and see angle 7 is an exterior angle. The problem with this is that angle 6 and angle 7 share the vertex L. Angle 7 is an exterior angle, but it shares the vertex with angle 6, so angle 6 is not remote in this case. Angle 6 is an interior angle, but it's not remote. So let's look at triangle LKM again, but extend a different side of the triangle. This time we create angle 3 as an exterior angle. I know that the measure of angle 6 plus the measure of angle 4 must add up to the measure of angle 3. Therefore, angle 3 has a greater measure than angle 6. I could also look at this larger triangle, triangle JKL. Again, I could extend it this way, but that's not going to help because angle 6 is touching the exterior angle. But I could also extend it this way. Now I see angle 8 is an exterior angle. The measure of angle 6 plus the measure of angle 1 must add up to the measure of angle 8. Therefore, angle 8 must have a greater measure than angle 6. So this problem has two answers, 3 and 8. Pause the video and try the practice problem below. Here are the correct answers. Now let's talk about inequalities between angles and sides of a triangle. Angles and sides are related because if one side of a triangle is longer than another, it means that the measure of the angle opposite that longer side is greater than the measure of the angle opposite that shorter side. And it works the other way around too. If one angle of a triangle has a measure greater than another angle, then the side opposite the angle with the greater measure is greater than the side opposite the lesser angle. Basically what this is all saying is that the longest side's across from the largest angle and the shortest side's across from the smallest angle, as shown in these pictures. Let's try an example of this together. So it says list the angles in order from smallest to largest. In order to find the angles, I don't know the angle measures. However, I do know the side measures. So I know the angles and sides are related because the smallest angle must be across from the shortest side. So I'll find my shortest side. My shortest side is PR. The angle across from side PR is angle Q. So I know angle Q must be the smallest angle. My largest angle must be across from my longest side. So I see my longest side is 9.1, side RQ. The angle across from the longest side is angle P. So I know angle P must be the largest angle. My medium angle then left over is angle R. So from smallest to largest in this triangle, I have angle Q, angle R, then angle P. Pause the video and try this practice problem below. We'll go over this one in class tomorrow. Now let's try it with side lengths. So this works similarly, but sometimes you might be missing an angle measure, like in this case. How could I find the measure of angle F? Well, I know that the measures of all the angles in the triangle added together must have a sum of 180 degrees. So I could solve this equation to find that the measure of angle F is 79 degrees. Therefore, I see that angle F is the largest angle, angle G is the smallest angle. So the side across from angle G is side FH. I know side FH must be the shortest side since it's across from the smallest angle. Next, I know angle F is the largest angle. It's across from side GH. So I know side GH must be the longest side. That leaves me with FG as my medium side across from the medium angle. Pause the video and try the practice problem below. Here's the correct answer. And that's all. Thanks, guys.